Hello, everyone. Welcome back to the TAG podcast. I am very excited to have Dr. Bill Andrews with us today, and we're going to be talking about longevity, anti-aging. I know you guys don't like the word anti-aging, but we're going to talk about anti-aging and how to live to, I don't know, 120, 185. I've heard all kinds of numbers. So we're going to crack the code today. We're going to find out what causes aging, how we can slow down aging, and how we can have a long and a healthy life. Dr. Andrews, welcome to the program.
Thank you very much. And I have to admit, I do get a lot of people saying they don't like the word anti-aging, and
Hmm.
that's only new in the last, like, I would say 5, 10 years.
Yes.
But it's like, how do we get away from that term? Because that's what we always use.
That's
The
right.
A4M, the American Association of Anti-Aging Medicine. I mean, one of the biggest things there's a lot things like that now, but it's a term. I sometimes stumble on what to use instead.
People
But
use
yeah,
pro-aging, which I don't like pro-aging at all because to me, aging is like, debilitation, cancer, arthritis, all of those things. I am not pro those things. So I am anti-aging and I don't care. I'm sticking to this term because I like it, but I get a lot of slack for using it. People don't like to hear it.
I haven't heard pro-aging sounds like let's encourage aging. Let's get as old as we
Exactly.
can.
Exactly.
I
That we have to be pro everything now. That's the new society. We have to embrace everything, pro everything. Well, I'm gonna fight aging, kicking and screaming tooth and nail for as long as I can. So that's me.
Me too. Me too. My goal is to cure my own aging just as much
That's
as everybody
awesome. I'm
else.
on board. Count on me. Dr. Andrews, tell us a little bit about yourself for those who might not know you, who you are, and what you do, and how you got involved in anti-aging.
Well, I've been obsessed with the whole idea of how bad aging is since I was 10 years old. And I have to say, this was because my father was very, like, against aging. He actually was a television producer. Years later, he was making a documentary on aging called "Aging Sucks," which he used to have bumper stickers saying that. But he ended up becoming president of a biotech company instead. And so that distracted him away from that. Like when I was 10 years old and he was realizing that I was really interested in science and medicine because my teachers were sending me home with notes pinned to my shirt. And my parents would open the notes and it would say, "Your son is incredibly interested in science and medicine. You should nurture this." So one time I'm out in the front lawn of my house in Canoga Park, California. He got this like 4 foot 8 inch, 4 foot long, 8 inch diameter telescope, reflector telescope, where I'm looking at Jupiter and Saturn and things like that. I'm running into the house telling my parents, "Oh, look at all the moons of Jupiter, look at the rings of Saturn," things like that. My father comes out to the lawn. He says, "Bill, since you're so interested in science and medicine, when you grow up, you should become a doctor and find a cure for aging." And then he said, "I don't know why nobody's done that yet." And it's like that stuck with me. And I remember, in fact, even when they made the documentary "The Immortalist" on about me about 10 years ago, which by the way almost won an Oscar. So it's a pretty good
Oh,
documentary.
congratulations. Wow.
Yeah, and uh, it's uh, it's called "The Immortalist," but my father's in it, uh, and and we talk about the fact that how he got me all started and stuff like that. And he and I were teammates. Now, during the making of that documentary, he started getting Alzheimer's and then passed away from Alzheimer's in 2015. So he's not part of the team anymore, which is unfortunate. But he was the main motivator. But I spent my entire life after that just like almost like what would you call it, a scavenger hunt, looking to build an arsenal of all the tools and everything I need to really understand what aging is and why we age and how we age. Because the only way I was ever going to figure out how not to age was to first figure all that other stuff out. I
Yes.
mean, was aging essential? How come we never evolved a way not to age? That kind of stuff. And so most people in the field don't even think about that kind of stuff. But I was I was thinking about that stuff even in anti-aging clubs that I had in high school and college. And in high school, it was just a group of friends that we'd just get together in one of the dorm rooms. I was at a private school, boarding school, so we'd get together and we just talk about these kind of things. And then I remember when I was in college, there was one of my best friends. In fact, my best friend in college was a guy named Bruce Boitler. He actually won a Nobel Prize in medicine in 2010, I think it was.
Wow.
But he was fascinated. He and I actually did research while I was in college on fruit flies, trying to study aging. But he one time told me that there'd been a publication that somebody had published that human cells can only divide a limited number of times. They're not like bacteria or yeast that when you grow them in a culture, they grow indefinitely.
Mhm.
Okay. Human cells, you start dividing them and they can only divide a particular number of times. And you can tell by how old they are when you get them, how many times they can divide before they stop dividing. And so we started thinking, one of the big problems is all the theories on aging didn't make sense. I always say all the twos and twos have to add up. None of them made sense. After getting my PhD, I applied for labs to work in labs all over the world to work on anti-aging. I got accepted to all of them, so I went and interviewed them. Then none of them made sense to me. So I went into biotech and worked on cancer and heart disease and inflammation research instead. But at the time, I kept thinking that while me and Bruce Boitler and the other people were still in college talking about this, what was called the Hayflick limit, the cells could only divide a certain number of times. That's the only thing that all the twos and twos added up on. It made sense that had to be something that was causing aging in humans. Not just, it was causing a limit to our lifespan, but it was also causing the changes that we see in ourselves as we get older. Or I don't like old, I like longer lived. Okay. So I
Yes.
like, so as longer lived we get, we see changes in our body. And so, but all that started making sense. And so we started asking the question, how could cells, human cells, know how many times they have divided already and how many more times they have to divide? Because human cells don't have brains, so they can't keep track of that stuff. So we said, how does a cell stop dividing without knowing that it's supposed to stop dividing? And we came up with the idea there had to be something like ride tickets at an amusement park, which
Mhm.
is my favorite analogy. There had to be something like that inside of cells. And every time a cell divided, the it lost a ticket somehow. Okay. And so so when after I was getting my PhD and I was interviewing at these labs, I kept talking to these people. Well, there has to be something like ride tickets at an amusement park. What are those? What explains the Hayflick limit? And everybody would say, "Oh, that Hayflick limit is completely bogus. Don't pay any attention to it." And I thought, well, that's wrong. These people are all being blind and stuff. So, but I couldn't figure out. I could not come up with anything that could be those ride tickets at an amusement park. So, as I said, I went into biotech instead as a senior scientist, and I had a very successful career in biotech. I've lots of cancer drugs I've invented, lots of I've invented human growth hormone, tissue plasminogen activator. And when I say I invented, the team I was with, I mean, there's no such thing as one person inventing anything anymore. But there's a whole bunch of them. But one day I was sitting at a conference, my father and I were sitting at an anti-aging conference in Lake Tahoe. And the speaker named Calvin Harley was speaking on stage, and he mentioned that every time a cell divides, the telomeres get shorter. Telomeres are the very tips of our chromosomes. They're like the caps on your shoelaces, except they're the caps on our chromosomes. And every time a cell divides, they get shorter by a very fixed unit of measurement. And he said that I can take blood from anybody. I can measure the length of their telomeres, telomeres, I can tell that person how old they are and how long they'll live before they die of old age. And
Amazing.
he said, better than any fortune teller.
Wow.
So before I'm sitting there and I'm saying, my God, here's the ride tickets. What I've been looking for all these years. Here's the ride ticket. So I I went up to him before he even got off stage and I said, has anybody figured out how to add ride tickets back, how to lengthen the telomeres back so they'd be longer, to see if this is actually affecting the aging process? Because showing that it correlates with aging doesn't mean it's causing aging.
Mhm.
But if you re-lengthen the telomeres and the person or animal that you're testing got younger, that would be proof. Especially if you then took the lengthener away and then allowed them to get shorter, and you saw that that animal or human got older again or longer lived again. He said no. He said we had been trying to figure out how to do that for years, and we've been working with labs all over the world, and we have not been able to figure that out. And I boldly said, let me come work for you, and I'll have it figured out in 3 months. He knew my background. He knew I'd probably had more success in biotech than anybody else on the planet. I'd already mentioned a few things that I was leading the discoveries of, but there's also beta seron, the very first drug for multiple sclerosis. One cancer drug that just got approved by the FDA called Rytelo, Rytelo. I invented those, but I had a very successful career, and a lot of people knew it. And so a lot of companies like Genentech and Amgen and things like that were contracting my company to help them with projects that they couldn't succeed on, specifically asking me to do it. Okay, so I had that kind of reputation back then. So Calvin Harley offered me the job on the spot. It was the shortest job interview ever. And I went and worked with him, and 3 months later, discovered the enzyme telomerase. Okay. And I say human telomerase because the enzyme had been discovered before 10 years earlier in a pond scum organism called tetrahymena,
Mhm.
but nobody had any idea that it had anything to do with aging or cancer or anything like that until I took the gene that we discovered in human cells and showed that not only could I prevent aging in human cells in a petri dish, I could also kill cancers, every single cancer, by accelerating their aging and by inhibiting this enzyme telomerase and therefore accelerating their aging. And it had zero effect on non-cancer cells. And so, but I was already, one of the things, I was already National Inventor of the Year for my cancer research. So I'd already, in the United States, so I already had a big reputation for cancer. So, but we did make a lot of big news about, there's a company made a lot of big news about this, about the fact that it inhibited cancer. And unfortunately, Geron Corporation, where I was at, suddenly decided, where the investors decided, well, God, we have a cure for aging and a cure for cancer all of a sudden at the same time. What are we going to do? We can't do both. And all the investors decided the quicker return on investment was to focus on cancer, even though Geron was short for gerontology. So that's what they did. And I said that I invented Rytelo at that time. And I said, but it won't work because it will inhibit telomerase. It will cause telomeres to become critically short, which will cause mutation rates to skyrocket. And therefore, mutations will allow the cancers to find ways to come back in all cases. And they said, oh, we don't care. And they did it anyway. And that's exactly what happened. And it took 30 years for the drug to actually get approved by the FDA because of all the cancers coming back. But they did finally get it approved. But I've always been interested in like poisoning cancer cells instead of inhibiting telomerase, just poisoning any cell that has telomerase. And that's something that I'm trying to do here at my company, CR Sciences. But as soon as Geron decided to stop all work on aging, even though their name was short for gerontology, I started my own company, Sierra Sciences, to continue that research. And so that's what I've been doing here for the last 25 years. And one of the reasons we're doing cancer is because I do consider cancer to be an age-related disease. Okay, the biggest cause of cancer is aging. But my major focus is to figure out ways of causing telomerase to be produced in all of our cells to keep our telomeres from shortening, and to also lengthen the telomeres even longer. Because one of the things that we found when we first did the experiment in human cells in a petri dish, when we grew human cells in a petri dish and treated them with telomerase, their telomeres didn't just stop shortening, they got longer, which was a surprise to us, but it was the first suggestion that begged the question that could we have actually reversed aging? Mm-hmm. And by every method of measurement that we had of testing human cells in a petri dish, it had reversed every marker we could look at. But that wasn't enough. So we grew human skin on the back of a mouse and treated that with telomerase. And again, we saw age reversal in every way imaginable, including loss of wrinkles, seeing blisters, formation of blisters decrease. That's actually published. So is the first one published. Then we provided the technology to Dr. Ron DePinto at Harvard, who had a really sophisticated mouse lab. And he was actually trying to show that telomerase would cause cancer, which I had argued, no, it's going to decrease the risk of cancer. But he thought, no, it's going to cause cancer. And so he created these mice that he could turn telomerase on and off, turn the gene on and off. And so he let these mice get really old, and he turned it on, expecting them to all get cancer, but none of them got cancer. In fact, fewer of them got cancer than before, but they all had a remarkable reversal of the aging process. As that was the term he used, remarkable reversal of the aging process, in an interview by Diane Sawyer, which is, people can Google it and just look for Dr. Ron DePinto, Diane Sawyer, and they can watch that news story that Diane Sawyer did about this study, because he was trying to show that they were going to get cancer. He was not, this is not a bias where he's trying to pretend that he got reversal of aging. He got reversal of aging by every method of measurement that you could imagine. One of the real exciting things was the mice that were suffering from dementia, couldn't remember how to go through a maze, were suddenly remembering how to go through the maze. And that has been a major change in a lot of people's thoughts about dementia, Alzheimer's, and things like that. So now when I speak at conferences on dementia, I oftentimes hear doctors saying Alzheimer's and other forms of dementia are not the loss of memory. They're the loss of access to the memory. The memory's still there. So lengthening telomeres could be a way of restoring normal cognitive functions to people suffering from Alzheimer's. I actually have a clinical study that I'm trying to get underway. People can go to clinicaltrials.gov and see the clinical study. I orchestrated it under a separate company called Libella, Libella. But we haven't been able to get it going because it cost me $1 million to treat one person once. Wow. with the gene therapy. Because all these studies, everything I've been talking about, it's all been using something called gene therapy to produce telomerase. So it's like a virus that you infect the cells with that delivers the gene. The gene's been turbocharged or changed so that it's on. So it's dimmer. Every gene has a dimmer switch that turns it on and off. We have it turned on maximum, just making tons of telomerase. So all these studies that we've done before have been with those gene therapies, and gene therapies are, one, expensive and also risky. Okay, so it's not the kind of thing that we can just start providing to people, even though they say they can afford it. But it was like everything seemed like, wow, this is really great. So I started Sierra Sciences to focus on trying to develop a small molecule whether it's from a plant extract or a pharmaceutical was not the point at the time. Just anything to try to understand, get something so we can start understanding the mechanisms of how to turn the gene on. And let me just go back a minute. When I first went to Geron, the way I discovered the enzyme telomerase was realizing that if every time a human cell divided, the telomeres got shorter, then our children should be born older than we are, because our reproductive cells are all having cell division. And so the production of the eggs and sperm are getting shorter and shorter telomeres. When they fertilize an egg, that fertilize an embryo to become an embryo, that embryo should have shorter telomeres than the parent did.
Mm-hmm.
But it doesn't. They're long. They're as long as the parents' telomeres were when they were still single cell embryos. So that's how we discovered telomerase, was looking at reproductive cells, but we didn't have to take an embryo or kill an embryo to do it, which is I'm totally opposed to. We were able to just collect primordial germ cells from people and stuff like that and be able to do that. And that was hardly invasive at all. The fact that our reproductive cells produce telomerase means that we had the gene for telomerase in all of our cells. But for some reason, which I didn't know at the time, it was just turned off. Okay. Well, I kind of knew at the time because I'd done my Ph.D. in molecular and population genetics. And population genetics, the reason why I got a Ph.D. in population genetics is because I was trying to understand why we age. Population genetics is not the what and when of evolution, it's the why and how of evolution. So why did we evolve an aging process, or why didn't we evolve a way not to age? So I had determined that the telomerase gene is going to be shut off in all of our cells because it's advantageous for our species to eliminate the longer lived after they've raised their young, because by doing so, that increases the chances that offspring will interbreed as opposed to parents rebreeding, because there's going to be a lot more diversity occurring from shuffling of genes that occurs from offspring breeding than the shuffling of genes from the parents rebreeding. And the more diversity that exists in a species, the more likely the species is going to have some members of the species that are going to survive rapidly changing environments. So for the last 4 billion years, our predecessors, it depends on if you believe in evolution or not, that somehow we have selected for, throughout evolution, selected for, I hate the word selection because that makes it sound like evolution is a force when it's not, it's just a result.
Yeah.
But any species that had a lot of diversity within it was more likely to survive the rapidly changing environment. So the ones that didn't have a lot of diversity, they were the ones that went extinct. So
that's such
why
an interesting perspective, because I've never thought of it that way.
it
Makes perfect sense.
One person thought of it that way, I want to say 100 years ago, and published it and was chastised by all the other people in the field of the evolution of aging that he retracted it. And I thought, why didn't he do that? Yeah. So, but I didn't know about it until I came up with the theory independently. But that's been, I wrote my PhD, not my dissertation, but my prelim dissertation that I had to do as an alternative to get in a master's degree. I wrote that on mathematical modeling of the explanation of why we've never evolved a way not to age. And I was actually trying to contradict a paper by Dr. Charlesworth. I can't remember his first name, and who had published a paper on mathematical modeling of why we age, and I totally disagreed with it. So I did my prelims on that, and that's what that was all about. So there's actually, if people went to my YouTube videos, they can find hour-long videos where I talk exactly about why we age and why we never evolved a way not to age. And I talk about this model that I just presented. And I can send you a link to all the videos.
Thank you.
Okay.
That's great. Why do you
But I've
think
got,
certain species, for example, they say lobsters never age? So
yeah, lobsters die
why do you think that happens?
because they have telomeres produced in all their cells.
So
Okay.
it's down to telomeres again.
Yeah, they don't have any telomere shortening. They
Wow.
also have no detectable aging whatsoever, and they never get diseases, including cancer. When I say never, I mean extremely rarely. Okay,
Yeah.
so there's always been a selection for, there's been a trend towards species that have an aging process are more likely to survive rapidly changing environments. But that doesn't mean everybody's been eliminated. There's still species on this planet that do not have any detectable aging. And that includes lobsters was the first one discovered.
Mhm.
And nobody knew this before because nobody ever looked at animals to see how long they lived. And the only way to know how long a lobster lives is to be there when it's born.
Yeah.
Um, so tortoises were that way, humpback whales, for
Octopus, right?
not, I don't think octopus. I've never heard
No?
octopus go to
Oh,
that list, but there's octopus is a really weird animal. In fact, there's so many differences between octopuses, sorry, than other animals that it's almost thought that it's a entirely separate life form
from a
created from.
different world, I was
Yeah.
reading. Yeah, it's quite interesting for sure.
The thing is that none of these animals had like rings on a tree where you could
Hmm.
measure their age, except one came along, and that was clams. Clams do have rings on a tree. They're stripes on their shells. Every year, clams get a new stripe. So you can measure calculate the age of a clam by just counting the number of stripes.
Wow.
And lo and behold, when people started doing this, they found clams are over 500 years old.
No
Have
way.
telomerase in all their cells, no telomere shortening, healthy, no aging, no cancer, nothing. Maybe a million years from now, they will age because
Yeah.
they're going to find out that their species is more likely to survive future rapidly changing environments by having more diversity within their species. But that's why we age. And I know we're
But
rambling all
you
over.
think this is the only, like it's all down to our telomeres, all the aging in humans?
Not at all. Not
No,
at all. I
okay.
just think that no matter what else we do to cure
Yeah.
aging will never be cured unless we also solve the telomere shortening
Mhm.
problem. Telomere shortening is the only absolute hard, fast limit to our lifespan that there is. It is absolutely impossible to live longer than 125 years because
But
of
it's almost
telomere
like
shortening.
we're pre-coded, like we're programmed this way. Our cells are programmed for death. We're given
Yes,
a certain lifespan and then finished.
that's exact. And the reason we evolved that is what I just said is it helped to eliminate the longer lived so that we can increase diversity within our species. But we're smarter than evolution now. We've done a lot of dumb things, but in evolution, but we are capable of now solving the aging problem and still surviving as a species. Thanks to people like Elon Musk, who's trying to get us to Mars and other planets and things like that. But in that studies, we started looking to see how many other animals age like humans do, because aging is a relatively recent evolutionary event. Okay, it actually aging did not exist before the evolution of sexual reproduction,
Mhm.
because before there was shuffling of genes from breeding, there was no advantage to having an organism age. But now all of a sudden there was. So aging evolved almost so shortly after the evolution of sexual reproduction that people can't distinguish between the two. They're so close. Did everything evolve aging by shutting off telomerase? No. Okay. As I mentioned, some animals didn't evolve an aging process yet. But some of them did other mechanisms, like mice and rodents, all rodents, mice, rats, rabbits, they don't age by telomere shortening,
Mhm.
even though there's a lot of studies on aging in those rodents, and a lot of them are measuring telomeres. The fact is, there is no Hayflick limit, as I mentioned before, in rodents. They don't
Interesting.
have telomere shortening. They have telomeres produced in all their cells. They have aging because they're not like lobsters, because they have extreme problems with oxidative stress and extreme problems with mitochondria dysfunction, and that's what's causing them to age. I mean, humans have oxidative stress problems and mitochondria problems too, and we're going to have to resolve those. But we've already have like 100 times more natural antioxidants than rodents do. That's why I say telomeres aren't the only problem. When we solve the telomere shortening problem, that might make us live to be 200 years old, but we still
Is
have
that
to.
possible? So you think you're saying that right now, the way we're coded, our maximum lifespan is about 125. But you're saying there is a potential with expanding our lifespan to possibly 200?
Yeah. I, I
Wow.
mean, I know it makes me sound like some fool saying that,
No,
because
not at all.
there's been quacks and charlatans in the anti-aging field for thousands of years, since before Cleopatra and stuff like that. But I think from a scientific perspective, uh, aging can be cured, and I want to cure my own aging. And the first thing that I've got to do is solve the telomere shortening problem.
Yeah.
But then, thank God, there's people like Aubrey de Grey and others that are working on the other problems, because we'll need those too. But if they don't get successful at solving those problems, that's what I want to do after I solve the telomere shortening problem, is go after the mitochondria dysfunction problems and the uh, oxidative stress problems, the other things that cause aging.
Yeah.
There's a whole bunch of theories on aging. There's the hallmarks of aging, but none of them are as explainable as telomere shortening. Okay. And that's why telomere shortening is not even a theory anymore.
Mhm.
Okay. It's a fact. I mean, anybody working with human cells in a petri dish know that their cells can only divide a limited number of times because of telomere shortening. And that puts a limit on our lifespan of 125. That's a hard, fast rule. It's not a theory.
Yeah.
But all the other theories they don't have any explanations as to how they happen. Like, why does methylation changes in the DNA occur
Mhm.
that correlate with aging? Okay. And nobody's figured out how to restore those methylation patterns to see if it reverses aging. But nobody understands, why is the body changing to make it so that DNA gets methylated in a different way? Telomeres.
Yeah.
Telomeres explain it perfectly. I mentioned that telomere shortening puts a limit on our lifespan, but they also actually have the ability to fold over onto the chromosome, come in contact with what I call dimmer switches, or they're called promoters. They're like dimmer switches that regulate genes on the chromosome. And these telomeres can turn these on or off by simply the proteins that are bound to the promoters. Okay, turn these dimmer switches on and off. And some of those genes are what are causing methylation,
Mhm.
or causing IgG glycosylation, or causing hand grip, or there's 1,000 different biomarkers of aging.
Yeah.
But reversing the biomarkers only reverses the biomarker. They never reversed aging. Okay. Telomeres is the only thing, lengthening telomeres is the only thing that's ever actually reversed aging, at least in these uh, mice and human skin growing on the back of mice. And I'd mentioned that mice, and I said also that mice don't age by telomere shortening. So
Mhm.
Dr. Rhonda Pinnell, that I mentioned before, he actually created a strain of mice that do age by telomere shortening. Okay,
Mm.
so kind of humanized mice to age like humans do. And that's why we provided the technology to him to test the aging on those. Uh, but but that's the only thing. Nothing else has ever been able to do that. The telomeres they have all the hallmarks of what are called enhancer sequences.
Mhm.
Enhancer sequences are sequences found throughout the chromosomes that can be like 100,000, if not a million bases away. So bases are what DNA is made of. They're like beads on a string. They can be 1,000, a million bases away. They fold over and come in contact with genes to turn the genes on and off. We've known that. I mean, when I was studying molecular genetics in the 1970s, my textbooks described that. Okay, it's something we've known for a long time. But I seem to be the only person that's recognized that telomeres have all the hallmarks of an enhancer sequence, including certain histones that bind, or acetylated histones that bind to the telomeres that only bind to enhancers otherwise. So these telomeres are folding over. They're acting just like enhancers, regulating the genes. And the reason that we see age-related changes in ourselves as we become longer lived is because as these telomeres get shorter, they can't reach as far,
Mhm.
okay? And so they regulate the genes differently. Enhancers don't get shorter, so they don't change with age, but
Mhm.
the telomeres do. And so in my videos, I talk about that. I talk about why we age. We talk about that's more how we age, and it's just phenomenal about how I've explained how we age without ever introducing any theories. I mean, I just explain it totally from facts. I mean,
Yeah.
aging was inevitable. There was no way to avoid it because of not theories, but just facts. And so I don't say the theories aren't true. I just say they're unnecessary.
Mhm.
We're going to age no matter what, okay? But we have to do something about it. And maybe the theories might be accelerating the aging, but and stuff like that. But telomeres are it. Telomeres are the main thing, and it's so difficult in this field of anti-aging to try to convince the world of this when there's so many charlatans out
There's
there.
so much out there. Yeah.
The fact that if you see that your telomeres are longer after a treatment than they were before,
Mhm.
that doesn't mean that the telomeres got lengthened. Okay. It means that in your blood, cells that, because you in your blood, you have cells of they have all different telomeres. Some cells have really short telomeres, some have really long telomeres.
But you can just do a normal blood test to check your telomere length.
And I recommend the number one company to do that with is called LifeLength,
Like,
LifeLength.
and are they only in North America or do they have this in Europe as well?
Their headquarters is in Spain.
Oh, okay.
Okay.
Well, right next door to me. Okay, sounds good.
So people in the United States can still get it done too because
Uh-huh.
they have clinics here that will collect the blood and ship it to them because they
Okay.
have a very proprietary procedure for measuring what are called the critically short telomeres. That's what I
Right.
like about life.
Right. Okay, I'm making notes. Yes, sounds good.
Okay, so but yeah, you can measure your telomeres. There's a lot of, and I'm the inventor or co-inventor of practically every method there is for measuring telomere lengths,
Hmm.
and
Wow.
also for measuring telomerase expression or activity,
Hmm.
um, expression and activity.
But
Um,
do you think we are born with like already a predetermined length? Like when you're born, can they already measure how long you're gonna live based on your
yes,
telomere? You can.
when, so when you were first conceived as a single cell embryo, try to remember where we were because I want to finish the subject we were just
Okay,
talking about.
sorry. I have so many questions in my head to ask you.
When we were first conceived, we have 250 ride tickets
Mhm.
at the tips of our chromosomes. Okay, that's equivalent to 15,000 bases of telomere sequence. Okay, because each ride ticket is about 40 bases, and you're going to find out that 15,000 doesn't actually correlate to 250 ride tickets. That's because the first 5,000 bases don't work. Okay, so it's really the functional part of your telomere is 10,000 bases when you're first conceived. Okay, that's 250 ride tickets. 40 bases per ride ticket. There's so much cell division going from being a single cell embryo to a newborn baby that when you're born, you've already used up half those ride tickets. Okay, so you only have 125 ride tickets left, 5,000 bases of functional telomere, 10,000 bases of actual repeats, the telomere repeats, but you have 5,000 bases left. Now you have a lot of growing to do, a lot of wounds to heal, a lot of infections to fight. So a lot of cell divisions going through your body constantly. And so you are still having telomere shortening. And when the telomeres get down to zero ride tickets, 0 bases left of the functional telomeres, you die of old age. And there's nothing you can do about it. Nothing you can do about it except to find ways to lengthen the telomeres, or you can find ways to decrease the rate of what I call accelerated telomere shortening, which is anything due to imperfect lifestyles or perfect genetics that cause accelerated telomere shortening. But you can't get you can't get more than essentially 125 years of functional life in your cells, unless we figure out a way to lengthen telomeres. And so that's what I've been working on. And none of us live to be 125. None of us at all, because of all of us have imperfect lifestyles. We all do things that accelerate telomere shortening. And the closest anybody's come is a woman named Jeanne Calment, but now it's been shown that her daughter took her place because of some kind of collecting alimony payments or something like that. And so now there's a lot of documentation proving that the woman that died at 122 was not Jeanne Calment. It was her
There was a
daughter.
lady in Spain who just died at 117.
Yes.
Yes.
Lots of people now have lived to be 117, 118, things like that. But there might be one person that lived to be 120, but that's now in dispute too. There's a woman, Natalie Coles, that I think should be talked to. Her ex-husband, he passed away from cancer, but he used to be the world's leading authority on centenarians and supercentenarians. So he would give the most amazing presentations at conferences, anti-aging conference. There's that term, anti-aging.
I'm happy with that, don't worry.
But he would give conferences, and he would always be like the keynote speaker because everybody wanted to know what's the real scoop on all these people claiming to be 120 and 130, things like that. And he would have proof proven they're all fakes, they're frauds. Marathon runners claiming to run marathons at 120. They were only 80 years old at the time, which is still good, but it's like they're trying to make money off of being celebrities. But he passed away. Natalie Coles has taken the baton, and you might want to interview her because she is somebody that's very knowledgeable about centenarians. And I can hook you up with her. Your telomeres in your blood can become longer by taking a toxin, okay? Because toxins will preferentially kill the cells with short telomeres, okay? And because cells with short telomeres have been published a lot to be very sensitive, more sensitive to toxins than cells that have longer telomeres. So toxins will cause your blood telomeres to get longer. The other thing that will cause your blood cells to get longer is anything that's immunogenic. If you're taking a treatment or a product that's causing an immune response, that's going to cause cells that are already in your bone marrow, that already have long telomeres because they have gone through very few cell divisions through your life. Now they start dividing, infiltrating your blood, putting new cells into your blood that have longer telomeres. So in both cases, getting rid of the cells with short telomeres or adding new cells to your blood that have long telomeres causes the average length of your telomeres to be longer, okay? Just as if you had a company, you're running a company, and you fired your dumbest employees, or you hired new geniuses, the average IQ of your company will increase
Mm.
without anybody getting any smarter. Okay.
Hmm. Yeah.
And this is what's happening. And this is why a lot of people are being misinformed, not intentionally necessarily, by people claiming that they have a product that causes your telomeres to get longer. But if they can't demonstrate that that product is producing telomerase, it is not lengthening your telomeres. In fact, everything, when you kill off cells with short telomeres, other cells have to divide to replace those cells, which causes telomere shortening. When cells in your bone marrow start dividing to infiltrate your blood, that causes telomere shortening there. So even though these products are lengthening your telomeres in your blood, they're actually accelerating aging throughout your body. Okay.
Wow.
And so it's something that you don't want to be doing. But I just say, instead of, I don't want to badmouth companies,
Hmm.
companies, products, especially since they probably don't know. Okay. But if they can't demonstrate production of telomerase, their product is not really lengthening telomeres. If they say that they didn't measure telomerase, then people have to ask, why not? Because measuring telomerase activity is easy to do. As I said, I'm one of the inventors or co-inventors of every procedure there is.
Hmm.
They can do that. So I am focused on just trying to find ingredients, things that will actually produce telomerase,
Hmm.
therefore lengthen telomeres. So now let's talk about what I'm doing here at Sierra
Yes.
Sciences. That's what we're doing. So we have robots here. They don't look like humans. They're like long benches with robotic arms that go up and around these rails and do different things. These robots have been trained to test up to 4,000 different plant extracts or chemicals or anything like that per day. They can test up to 4,000 per day, looking for anything that induces the production of telomerase or induces the expression of the telomerase gene, which is a lot easier to measure, in human cells. And so we've tested like over 500,000 different chemicals.
Wow.
But what's most important is, because chemicals, they'll take forever, like to get approved by the FDA, $2.6 billion average clinical study test. So we've also been testing plant extracts. So what I want to say is fractions of plant extracts. A plant extract typically has about 200,000 different types of molecules in it. So whenever you take a plant extract, there's going to be molecules that do everything imaginable in your body.
Yes.
And so what you do, some reasons why one plant extract works better than another for doing something is because the active ingredient, the one molecule of that 200,000 that's doing something, actually doesn't have something that's actually undoing what it does.
Hmm.
So we make fractions. We separate the molecules in terms of size, solubility, charge, a bunch of other things. We'll have like 30 different fractions of each plant extract, and we'll test them with our robotic systems looking for something. And we have found, overall, we've found probably 900 different molecules that will induce the production of telomerase in human cells. But about 40 to 50 of those are fractions of plant extracts. And because they're from a plant extract, they're already got the classification of generally regarded as safe by the FDA.
Hmm.
So they don't need clinical approval.
But they would
So
fall under like a dietary supplement category. Hmm.
actually, okay, so that's what my preference is right now, because it's going to take years. Not only does it cost $2.6 billion on average to get a drug through FDA clinical studies, it takes 15 years too to do this. We are doing that. Okay. We're also trying to do that with gene therapy. As I mentioned, that costs us $1
Yes.
million to treat one patient once. But the thing that I'm focused on most now is on these plant extracts. So now, before I get to the coup de grace here, uh,
Okay.
it, it's telomere shortening and lengthening is like a tug of war.
Hmm.
Okay. So we have shorteners pulling to lengthen or shorten, and we have lengtheners pulling to lengthen. The only thing that lengthens is telomerase. That's the only thing in the human body ever discovered that can lengthen telomeres, is the enzyme telomerase. So in our reproductive cells, the cells divide, the telomeres get shorter, then telomerase re-lengthens. Divide again, the telomeres get shorter, telomerase re-lengthens. That's only true in our reproductive cells because, and it's a tie. It's the tug of war is a tie. But in all the other cells of our body, there is no lengtheners. It's zero, undetectable zero. So every time a cell divides, telomeres get shorter. Cell divides again, telomeres get shorter again. So what we have done is we have found nutraceuticals that will actually induce production of telomerase to produce enough telomerase to put people on the lengthening side of the tug of war. Okay, but we haven't found something strong enough to win that tug of war yet. So still, the cell divides, the telomeres get shorter, telomerase comes in, lengthens a little bit. Mm-hmm. Cell divides again, telomeres get shorter, telomerase comes in and lengthens a little bit more. So we are decreasing the rate of telomere shortening with these nutraceuticals that we've discovered. But we're not winning the tug of war yet. Okay, let me also say, before we get to the coup de grace, we also have studies. In fact, there's other labs that have published the same thing. Peer-reviewed studies have shown that when telomeres get really, really short, they become easier to lengthen. Okay, so even with low levels of telomerase, you can lengthen the critically short telomeres, which could be causing symptoms of appearing to be age reversal. The reason why, nobody knows why the short telomeres are easier to lengthen, but the analogy that I like, that I've invented, is that telomeres are not this straight linear string of beads like everybody says they are. They're folded up like a ball of yarn. Okay, and the tip of the telomere is buried inside the ball of yarn, and so telomerase can't get to it when the ball of yarn is big. But when the telomeres get really short and that ball of yarn gets small, then telomerase can get to it and lengthen them, even with low levels of telomerase. So we have found like 40 to 50 nutraceuticals that will lengthen telomeres, but not enough to win the tug of war. And we have provided the top 5 to a company called Touchstone Essentials that has mixed them together and is now providing them as a product called TeloVital. I thought I had a bottle here in front of me, but I think
we can put one on the screen. My editor can do that.
I'm not a marketer. You haven't heard me market at all during this interview.
No, it's fine. I'm very interested.
I'm very excited about this product because I think it's the absolute best thing that anybody could be doing to decrease the rate of their aging for real, not pretend. And I take this product every day. Every person in my family does. All my friends do. It is the #1 best thing anybody could be doing. So I'm not a marketer. I've explained the science.
Tell us some of the things that you and your family members have noticed since taking this supplement. What has changed?
Well, see, that's why I brought about this short telomere stuff before, is because you really shouldn't see any changes. It should be with the low levels of telomerase, it should only be slowing down the rate of aging, which means you wouldn't see any changes. But people are seeing changes. I've seen changes. I'd be blind. I'm a scientist. I don't go with anecdotal data, but I'd be blind to ignore the fact that a lot of people that are taking TeloVital are coming to me and saying they are seeing some major changes. Now, I have seen better vision. My vision's getting better. You know, if I put my glasses on right now, I'd be having a hard time seeing you right now. My endurance is getting better. I'm an ultra marathon runner.
Wow.
If anything like improving my endurance is really good for me.
Yeah.
People are seeing, people are seeing hair coming back, hair color coming back. they're seeing cognitive skills getting better. Now, none of these, I mean, not everybody's going to see their hair come back or their hair color come back. It depends on why you lost your hair or why your hair turned gray or white or whatever.
Yeah.
If it was caused by telomere shortening, then you should be able to see your hair come back and your hair color come back because the critically short telomeres getting longer. But some people, everybody, a lot of people know that male pattern baldness is typically caused by inheriting a gene from your mother's father.
Mm-hmm.
Okay, well, that's not going to help that person.
Mm-hmm.
Okay, but if you have lost your hair because of accelerated telomere shortening in your scalp, therefore giving you critically short telomeres in your follicle cells in your scalp, you can get those cells to come back by lengthening the critically short telomeres. And but I'm getting all kinds of things, like people saying that they have fibromyalgia and they don't have it anymore. And that's something that's almost every disease on the planet has now been published in one peer-reviewed journal or another, showing that telomeres play a role in causing that disease, including the common cold. Okay, so your immune system should come back if your immune system is in a phase of what's called immune senescence.
Mm-hmm.
And senescence is caused by the Hayflick limit. So when cells reach a Hayflick limit, they go into senescence. Immune senescence means that your immune cells have now gone into the Hayflick limit. Lengthening the critically short telomeres should bring your immune system back.
Mm-hmm.
People are saying their autoimmune diseases are disappearing. Okay. I mean, there's no scientific data yet because this is all anecdotal, but it's amazing what people are seeing. And there are groups getting together, and oftentimes I will speak to these groups, but they're all claiming, wow, all these things are happening to them. And I believe them, some of them. And the people that are noticing the most improvements are the people over 90 years old. Okay.
Wow.
There are people on some of these calls that are now dancing, doing things, having the time of their life. Their before and after pictures are just amazing. Videos of them before and after are amazing. And they're getting up and they're all excited talking about how much fun life is again.
Wow.
But people can find out about these groups. They can contact me. I can have them join some of these groups. They can actually listen to some of these people talk, because these people are addicted to telling how great their lives are now. But yeah, it's I'm trying to not be a marketer, but it's like too hard not to be with this product. But the science is legit. The science is valid. It's cheaper than it used to be. Televital has the most potent telomerase inducers on the planet.
So, Dr. Andrews, this product sounds absolutely amazing, and all the information you gave us today is mind-blowing, and so much new information, even for me, and I've been researching anti-aging for decades as well. Can you please tell our listeners how they can find out more information about you, how they can follow you? You also have a podcast, correct?
Yes, I have a podcast called Up One, which is all
One.
about doing critical meta-analysis of peer-reviewed studies to find out what's real and not real, because there's so much in the nutraceutical, pharmaceutical field, there's so much fraudulence and stuff like that, that people can get peer-reviewed studies even by faking data. So I'm really good at, because of all my learnings, I'm good at reading papers and figuring out if the paper's legit or not. So it's called Up One because I take it up a notch in analyzing meta-analysis of peer-reviewed studies. So I call it critical meta-analysis of peer-reviewed studies. But yeah, I think people could really benefit from watching these podcasts, because they'll learn a lot about what's real and not real. But if they want to know more, I do have a website, but because of the fact that I'm just a research company, all I do here is basic discovery research. Okay, there's no need for us to have a really sophisticated website. So right now it's even down, but it could be up quick. But it's www.cellular, Sierra Sci, SIERRASCI, short for Sierra Sciences,
Mhm.
.com. They can go there, and there they can find a list of key videos and documentaries that I've been in where I talk about how we age, why we age, how what aging is, and how not to age. I
Mhm.
talk about those different things in a way that everybody agrees. Okay, it destroys all the theories, but I've never had anybody come back and say I'm wrong. Okay, but so people should listen to this because I don't know anybody that has done more studying of what all these things about aging are than I have. Um, and but a really good place to go to learn about what I'm doing, because my website's really not that great, is go to Touchstone's website, Touchstone Essentials.
Mhm.
That's www.thegoodinside.com. And there they talk about the product. They show our data. They show
Mhm.
our data that shows that telovital
Yes.
induce the expression of telomerase. Okay. And so I challenge everybody to go find some other company that shows any data like that whatsoever.
Yeah.
Uh,
No, it's amazing. I'll
and
make sure to link everything in the show notes so people can easily find you any information on this product as well.
I do something that most people don't do. I'm going to provide you with my email address because I spend half my day or more than half my day in the lab. But right behind my wall here is 10,500 square feet of lab space, including the
Wow.
robots that I mentioned. But I like to every once in a while take a break, go in my office, and I like to read emails, okay, and respond to people asking questions about aging in general. Okay, so people can email me if they got questions. My email address is B as in boy, Andrews, so BANDREWS at sierrasci.com, just like Sierra Sci when for the website, SIERRASCI.com. And I look forward to getting emails from people with any questions.
Wonderful. Sounds amazing. And thank you so much for explaining everything, in a simple language so that anyone can understand, because this is quite complex. And, sometimes I have people on the show and it just goes so quickly and it gets so complicated that it's difficult to follow. But you just explained it so clearly and it was so easy to understand. I really, truly appreciate that. And I appreciate your time and thank you so much for coming on the show.
Thank you. I love talking about this stuff. All right.
Your
Well,
passion shows and I love it. Thank you
all right.
very much. And thank you everyone for watching, and we'll see you guys in the next one. Thank you guys so much for watching this episode. And I have two very important things to tell you. So please stick with me for just one more minute. The first one is if you enjoyed this episode and if you like my show, please make sure to like and subscribe because this is so important so that it gets out there to as many people as possible. People don't realize how important those things are. You think you just watch, it pops up in my feed or whatever, but it's really, really important to support the podcast that you guys truly believe in. And the other one I want to mention to you guys is my new book. So if you're a menopausal lady, or getting near the age of menopause and you want to go through menopause naturally, then this is the book for you. The 30-Day Natural Menopause Reset. This is my third book following two bestsellers. And I'm so excited about this book. It's already changing a lot of lives. You can read some of the reviews on Amazon. And if you're not ready for HRT and you want to overcome your symptoms, weight gain, anxiety, sleeplessness, so many things that happen to our bodies. It's like you feel like you've lost control over your own body. So this book can really change your life. You can find it on Amazon. And that's it, guys. Thank you so much for watching.